So my dear students, today we discuss about the last optical instrument, which is telescope. So previous class we discussed about the microscope, that means simple microscope and open microscope. So today we discuss about last optical instrument known as telescope. Okay, so telescope means the optical instrument used to see the far object. Telescope is the optical instrument used to see the far object. That means the object situated in far distance from the earth. Okay, so that optical instrument is known as telescope. Okay, so this telescope generally we get two type of telescope. Generally we get two type of telescope. So first one is refracting telescope. Refracting. That means here lens is used. In this type of telescope generally lens are used. And second one is reflecting telescope. First one refracting and second one reflecting telescope. In refracting telescope we use lens. That means in refracting telescope lenses are used, and in reflecting telescope mirror are used. Okay, so this refracting telescope is divided into two types. Refracting telescope is divided into two types. So first one is refracting telescope. It is astronomical telescope. Astronomical telescope. Okay, it is used. Astronomical telescope is used to see the object. That means star, planet, and the object situated at a high distance from the earth. Okay, that means astronomical telescope is the device used to see the object situated at a far distance from the earth. So that means moon, planet, galaxy, this type of object can be seen by this type of telescope, astronomical telescope. Okay, so next another one which is used to see the object on the earth, who's used to see the far object, far distance object on the earth. That means suppose tree, house, that means distance object. Okay, so that telescope is known as terrestrial telescope. Okay, so first one is astronomical telescope and second one is terrestrial telescope. In terrestrial telescope, virtual and inverted images are formed. In astronomical telescope, virtual and inverted images are produced. But in terrestrial telescope, virtual and erect images are produced. In astronomical telescope, virtual and inverted image, and in terrestrial telescope, virtual and erect images are produced. Okay, so that means in this telescope lenses are used. That means convex lens or concave lens. That means lenses are used. Next, in reflecting telescope, mirror are used. It is also divided into two types. Number one, Cassegrain telescope, and number two, Newtonian telescope. So further we discuss about the refracting telescope. Now we discuss about astronomical telescope. That means now we discuss about what? That is astronomical telescope. Okay. Now we discuss about, so students see, in astronomical telescope, it is similar to compound microscope. Okay, here two lenses are used. This is known as objective, and this is eyepiece. Okay, so this is objective and this is eyepiece. The focal length and aperture of objective is larger than the focal length and aperture of eyepiece. Okay, in compound microscope, what happened? Compound microscope case is focal length and aperture of eyepiece is high, that means larger. But in telescope, that means astronomical telescope, focal length and aperture of objective is greater than the focal length and aperture of eyepiece. Okay, here also both the lenses are placed coaxially. Okay, so in telescope, object is situated at infinity. Telescope object to infinity. So the rays of light coming from the object, are incident on it like this. Okay. Rays of light coming from the object are incident on it. It is passing through this optical center. Okay, so this is optical center. So another ray is converging beam of light coming from the object situated at infinity are incident on it. Then after refractions, they are converged and they meet at a point. Suppose this point. This is point, in which a real image is formed. Suppose this is real image A, B. So here also in astronomical telescope we get two measurements. First one is normal vision and second one is distinct vision. But here in SS syllabus, it is include only normal vision of astronomical telescope. Yat all telescope kontu vision ase, normal vision ase. Gotike ami hetu kotha discuss korim. Yat kono distinct vision opor yat kono dia nai. Ekos amar course of vision eko dia nai. Hetu kane ami distinct vision to discuss korom. Thik ase? So we discuss about only normal vision of what? Normal vision of astronomical telescope. So in normal vision of astronomical telescope, what happens? So in normal adjustment, first to see, in normal adjustment, the focus of both the lenses are coincide to each other like this. Focus of both the lenses are coincide to each other. Duikhon lensor focus to এইখন লেন্সৰ ফোকাসটো আৰু এইখন লেন্সৰ ফোকাসটো কি হৈছে coincide হৈ আছে ঠিক আছে so object is situated at infinity so image will be formed at focus for objective lens okay so this image here AB be the image of objective okay so this image is used as a object by eyepiece which is placed at the focus of eyepiece okay so we know if a object is placed at focus then final image is formed at infinity okay so in normal adjustment what happened both the lenses are placed coaxially the focal length and aperture of objective is larger than focal length and aperture of eyepiece okay the ray of light coming from the object are incident on the lens then after refraction a real and inverted image is formed at the focus at the position of focus of eyepiece real and inverted image AB is formed where it is formed at the principal focus of eyepiece okay so this image is used as a object by eyepiece then final image is formed at infinity okay so this is another ray if if the image of objective or image to the eyepiece image হিসাবে use করে then অবজেক্টিভৰ ইমেজটো যদি আইপিছে অবজেক্ট হিচাপে ইউজ কৰে, then ray of light, one ray of light coming like this, okay, another ray incident on it, and it becomes parallel. It is moving to the eye. Then they are extend on back side like this. They are extend on back side. So it is infinity. Infinity. ঠিক আছে, ধৰ পাইছা? This আইলে গৈছে আৰু ইফালে ইমেজটো ক'ত ফৰ্ম হৈছেগে? ইনফিনিটি ফৰ্ম হৈছে। এইটো ক'ত গৈছেগে? মই ডাঙৰকৈ লিখিছো ইনফিনিটি। Infinity. Huh? So here, this is F naught and this is Fe. Fe. So now, angular magnification. This is alpha and this is beta. This is alpha and this is beta. So now, angular magnification. Angular magnification is m equal to tan beta divided by tan alpha. So this tan beta equal to perpendicular by base, this AB by AE, and tan alpha equal to AB by AO. Then AB cancel, then we get AO by AE. So this AO means FO and A means FE. FO means focal length of objective and FE means focal length of eyepiece. So in case of normal adjustment, this distance is known as length of the tube. This is L. L equal to F naught plus Fe. Length of the tube. Tube means in which both the lenses are placed coexist. That means length of telescope. It is length of tube. L equal to F naught plus Fe. So this is the magnifying power of astronomical telescope. It is a astronomical telescope or normal vision of magnifying power. Yes, here distinct vision is not required. Distinct vision is not required. But what happened? In distinct vision, this image is formed at that position. That means image of object is formed at a position. Suppose this position. Image of objective is formed in this position. So this image is used as a object by eyepiece. Then final image is formed at a distinct vision. That means distant position, that is 25 centimeter. That here distinct vision of final image to form hoge 25 centimeter form. ঠিক আছে, সেই কম্পাউণ্ড মাইক্ৰস্কোপত যেনেকৈ ফৰ্ম হৈছিলে তাৰ ক্ষেত্ৰতো সেই একেটাই হ'ব। ঠিক আছে, আমি সেইখিনি আমি ইয়াত ডিৰাইভ নকৰোঁ। হ'ল। চ' টেৰেষ্ট্ৰিয়েল টেলিস্কোপ তাতো আমাৰ তাত বিষয়ে ইয়াৰ ওপৰতো আমাৰ অলৰেডি ইয়াত নাই বিশেষ। টেৰেষ্ট্ৰিয়েল টেলিস্কোপৰ কোনো মেথমেটিকেল এক্সপ্লেনেশ্যন নাই। In terrestrial telescope, what happened? We know in terrestrial telescope, three lenses are used. So here, virtual and erect image is produced. In astronomical telescope, 2 lenses are used, but in terrestrial telescope, 3 lenses are used, for which virtual and erect image is formed. Okay, virtual and erect, but here virtual and inverted image is formed. Okay, so in telescope, already we have seen, in telescope, lenses are used. But we know case of lens. Compound microscope already dekhise. In case of lens, aberrations takes place. In case of lens, aberrations takes place. Okay. So therefore, image formed by the telescope will be blurred. Image to ki hobo amar blur hoi jabo. Zilmili khela. Tumi focus kono, bhalke focus koribo noro. Buji na? In case of telescope, due to spherical aberration and chromatic aberration, the image will be not clear. Image to amar clear no. Therefore, some difficulty will take place. To remove this difficulty, reflecting telescope are used. ঠিক আছে সেই ডিফিকাল্টিটো ৰিমুভ কৰিব কাৰণে আমাৰ কি ইউজ কৰা হ'ল ৰিফ্লেক্টিং টেলিস্কোপ ইউজ কৰা হ'ল ঠিক আছে আমি ৰিফ্লেক্টিং টেলিস্কোপলৈ যোৱাৰ আগতে আমি আৰু কেইটামান টেলিস্কোপৰ লগত ৰিলেটেড বা অপটিকেল ইনষ্ট্ৰুমেন্টৰ লগত ৰিলেটেড কিছুমান সৰু সৰু কথা কিছুমান আমি ইয়াত ক'লে আমি চাই ল'ব লাগিব ঠিক আছে সেই টপিক কিটা আপোন আমি এতিয়া চাই লৈছো গতে সেই টপিক কিটা আমাৰ কি দিয়া আছে হনে এতিয়া চোৱা যেতিয়া আমি এই পইণ্ট কিটাৰ ওপৰত চাওঁ ইয়াত আমি টেলিস্কোপৰ ক্ষেত্ৰত বা অপটিকেল ইনষ্ট্ৰুমেন্টৰ ক্ষেত্ৰত আমি এটা পইণ্ট পাওঁ এটো হৈছে যেনেকে এংগুলাৰ ম্যাগনিফিকেশন পাওঁ ঠিক হৈদৰে আমি ইয়াত পাওঁ কি ৰিজলভিং পাৱাৰ ম্যাগনিফাইং পাৱাৰ এন্ড ব্ৰাইটনেস যেটো কোপাৰি লাইট গেদাৰিং পাৱাৰ লাইট গেদাৰিং পাৱাৰ মানে ব্ৰাইটনেস ঠিক আছে কিছুমান আমি প্ৰপাৰ্টিজ পাওঁ হল টেলিস্কোপৰ ক্ষেত্ৰত বা অপটিকেল ইনষ্ট্ৰুমেন্টৰ ক্ষেত্ৰত আমি কি পাওঁ কিছুমান প্ৰপাৰ্টিজ কিছুমান পাওঁ যিবিলাকৰ ক্ষেত্ৰত আমাৰ ইমেজ ফৰ্মেশনত এফেক্ট কৰিব পাৰে লাইট গেদাৰিং পাৱাৰ যেটো ব্ৰাইটনেস বুলি ক'ব পাৰি নেক্সট আমি ক'ব পাৰিম ৰিজলভিং পাৱাৰ হল আমাৰ ইয়াৰ ক্ষেত্ৰত কি হৈছে মিৰৰৰ ক্ষেত্ৰত টেলিস্কোপৰ ক্ষেত্ৰত গেদাৰিং পাৱাৰটো আৰু ৰিজলভিং পাৱাৰটো সেই দুটা ওপৰত বেছ কৰি পেলাই আমি এটা টেলিস্কোপ আৰু মাইক্ৰোস্কোপৰ কোৱালিটিটো আমাৰ ডিপেন্ড কৰে যদি কোৱালিটিটো হাই কৰিবলগীয়া হয় মানে এষ্ট্ৰোনমিক্যাল টেলিস্কোপ ইউজ কৰাৰ মেইন পইণ্টটো কি জানানে what is the main consideration of astronomical telescope it is light gathering power and resolving power tar ki hoise gathering power and resolving power to komi ase light gathering power main consideration of astronomical telescope is light gathering power and resolving power this ami he point to ami sapre eta resolving power mane ki what is resolving power light gathering power mane hoise brightness it is depends on diameter of the lens that means area of the diameter of the lens area of the lens jikhon ami objective lens use koru সেই objective lens khonor jitu area সেই area to upor depend kore brightness is directly proportional to the area of the objective lens ঠিক আছে objective lens khonor area to upor depend koribo etia সেই বস্তু চাইছো light gathering power power যিটো আমি LGP বুলি কব LGP light gathering power what is light gathering power it is the brightness light gathering power is the brightness of the image formed by the telescope so this light gathering power it is the brightness of the image formed by the telescope so this LGP is directly proportional to the area of objective lens so we know area of objective lens has a definite diameter okay the objective lens has a definite diameter if capital D be the diameter of the lens that means objective lens then LZP is directly proportional to pi d square divided by 4 eto more rakhiba light gathering power how light gathering power is related with diameter jimane diameter to bahi jabo simane brightness to bahi jabo mane এৰিয়াটো যিমানে বাঢ়িব সিমানে লাইট গেদাৰিং পাৱাৰ লাইট মানে পৰিব পৰা পাৱাৰটো বাঢ়ি যাব সেইটো কাৰণে কি বুলি কয় ব্ৰাইটনেছটো বাঢ়ি যাব ঠিক আছে in case of telescope we have required high intensity high brightness to বঢ়াব লাগিব so to increase the high brightness or light gathering power we have required large diameter of the lens but large diameter of the lens is large diameter of the lens it is more difficult to set up in a telescope that means for manufacturing for arrangement high that means large diameter of the lens is not preferable আমি large diameter of the lens খন যদি পাও তেতিয়াহলে ব্ৰাইটনেছটো বাঢ়ি যাব ঠিক আছে কিন্তু সেইটো পাবলৈ হলে আমাৰ লেন্স খনৰ ডায়ামিটাৰটো বহুত ডাঙৰ হ'ব লাগিব so in that case this setup will be that means in that case the lens will be large lens খন বহুত ডাঙৰ হ'ব লাগিব but it is not suitable সেইটো কিন্তু আমাৰ suitable নহয় বুজি পাইছা so this is the main drawback of astronomical refracting telescope বুজি পাইছা সেকেন্ডটো আমি পাইছিলো কি গেদাৰিং পাৱাৰ মানে সৰি কি বুলি পাইছো spherical aberration আৰু chromatic aberration so this is the another one disadvantage that is drawback of astronomical refracting telescope to avoid spherical aberration or chromatic aberration we have required mirror that means spherical aberration can be avoided if we use mirror as a objective instead of lens if we mirror as a objective in telescope instead of lens then spherical aberration and chromatic aberrations will be removed okay so this is drawback actually and another one drawback is light gathering power okay so in case of astronomical telescope to increase the brightness we have required large diameter of the lens but large diameter of the lens is not preferable for manufacturing okay so next is resolving power resolving power RP so what is resolving power resolving power is the ability it is the ability of a lens resolving power is the ability of a lens to focus distinctly and separately to distant object to close distant object distinctly and separately focused by an optical instrument okay so this ability is known as resolving power so what is resolving power it is the resolving power is the ability to observe to distant object distinctly and separately ঠিক আছে so this resolving power is inversely proportional to the angular separation or limit of resolution that means resolving power is inversely proportional to angular separation it is inversely proportional to resolving limit so what is resolving limit resolving limit is the angular separation of two closely distant object it is the Resolving limit is the angular separation of two closely distant objects. Suppose this is an object, this is an object. So this is angular separation. Suppose this angle is known as angular separation. Suppose this angle is d alpha. So this is known as resolving limit. Okay. So from this we get in telescope RP is equal to 1 by R 1 by d alpha equal to d by 1.22 lambda. RP equal to 1 by d alpha equal to d by 1.22 lambda, where this d alpha, this is resolving limit, and capital D, what is capital D? It is diameter of objective lens, and lambda be the wavelength of light used. Lambda be the wavelength of light used. So this is resolving power of telescope. Next, in microscope, RP equal to 1 by d alpha equal to twice mu sin theta divided by lambda. Twice mu sin theta by lambda. So this mu sin theta, this twice mu sin theta by lambda. So this part is known as numerical aperture. This mu sin theta is known as numerical aperture. Okay, so if mu sin theta is increased, then resolving power is increased. If lambda is decreased, resolving power of microscope is increased. In telescope, if diameter of the objective lens is used, increased, then gathering power will be increased. So in that case, resolving power is increased. If lambda is increased, then resolving power is decreased. So from this we get resolving power is directly proportional to diameter of objective lens and directly proportional to mu sin theta of microscope and inversely proportional to wavelength of light used. So these are the factors depends on resolving power. These 3 points to be noted. Okay, so these 3 points, how resolving power is affected of an optical instrument. First point, resolving power is directly proportional to diameter of lens. Second point, resolving power of microscope is directly proportional to numerical aperture of the lens, that is numerical aperture of the instrument, and is inversely proportional to wavelength of light used in telescope and microscope. Okay, so this is the telescope, that means refracting telescope. So in case of reflecting telescope, we get reflecting telescope, mirror are used. So it is a symmetric diagram, that means reflecting telescope. There are 2 types of reflecting telescope. First one is Cassegrain telescope. Second one is Newtonian telescope. Okay, so in your syllabus, we get only Cassegrain telescope. World largest reflecting telescope, that means largest reflecting telescope in the world is known as Keck telescope. K-E-C-K, Keck telescope in Hawaii. Keck telescope, largest reflecting telescope in the world is Keck telescope. Okay? Ekhini topic opor ami already paisho. Gotike yar pasot duta diagram ase. These two diagrams can be easily drawn by your book. Okay, this is Cassegrain telescope. Okay, in Cassegrain telescope, a concave mirror, that means two concave mirror, and a convex mirror is used. Okay, so these two diagrams can be easily drawn. So now, so dear students, see, this is Cassegrain telescope and this is Newtonian telescope. First you see in Cassegrain telescope, so these two mirrors, these and these two mirrors are concave mirror. This is concave and this is convex. So this parallel beam of light coming from the object are incident on it, on the concave mirror, then after reflections, এইটো এটা টিউবৰ ভিতৰত লখাই থোৱা আছে এনেকে এটা টিউব দেই এটো বস্তুটো গুটেটো এৰেঞ্জমেন্ট এটা টিউবৰ ভিতৰত লাগি ৰখা হৈছে so here the mirrors are set up inside a tube okay so these two mirrors are concave mirror the parallel beam of light coming from the object are incident on it then after reflection it is again strike on the convex mirror okay so next another parallel beam of light incident on the concave mirror then after reflection again it is reflected towards the convex mirror that means after reflections in concave mirror this reflected ray is incident on convex mirror then after reflection of the convex mirror they are meet at this point like this they are come back that means at this point then finally show a lens it is moved to our eye finally show a lens that means eyepiece it is moved to our eye so here object is the ray of light coming from this side and here we see the image in this position okay that means object is situated at infinity in Cassegrain telescope that means in Cassegrain telescope objective and eyepiece that means object and image both are placed in same line suppose okay but that means same direction but in Cassegrain telescope concave mirror is used and here a plane mirror is also used here it is plane mirror so same phenomenon parallel beam this is parallel beam and this is parallel beam this parallel beam are incident on the mirror concave mirror after reflection this reflected ray is moving into the plane mirror that means reflected ray incident on plane mirror this ray also incident on this concave mirror and after reflection in this point it is moving towards the plane mirror then after reflection in plane mirror it is moved towards the eyepiece that means in that case object is placed in this position but here we see the image in this position that means we can determine the position or location we can determine the location and direction of the object directly in Newtonian telescope but in Cassegrain telescope we can determine the direction and position of the object easily determined in Cassegrain telescope but in Newtonian telescope there is a difficulty okay so this is the Cassegrain and Newtonian reflecting telescope so here there is no mathematical explanation so what is the in telescope we get what is the main consideration of astronomical telescope etu agota ahi goise main consideration of astronomical telescope is light gathering power and resolving power first point that means in next ki paisilo why mirror are used because mirror are used in telescope because in astronomical telescope lenses are used for which spherical and chromatic aberrations takes place. To remove this difficulty, parabolic mirrors are used in which the aberrations does not take place. Next, to increase the gathering power, light gathering power or brightness, mirrors are used. That means, to increase the light gathering power, we should increase the diameter of the lens or mirror. But high diameter of the lens is not preferable for manufacturing. Okay, so there is a problem. Okay, so this is the simple explanation of telescope. Okay, thank you.